Hi, hello. I'm fine. You can talk Bengali. Obviously, I can. Hemoglobin is a red pigment of blood. Hemoglobin acts as an oxygen carrier. আমি ড্রপার, ক্লাস 12 পাস করেছি রিসেন্ট ইয়ারে। ভিটামিন B12 বা সায়ানোক্লোরাইড। I'm doing class now. It's a study block. I'm doing class now. Please like and subscribe my channel. I need your support. Please like and subscribe my channel. See, I'm doing my class on YouTube. Please like and subscribe my channel. Compounds, coordination compounds of great importance in biological systems. So they are the coordination compounds of great importance. Coordination compounds of great importance in biological systems are the coordination compounds. First one is chlorophyll, and coordination compounds of great importance. Coordination compounds of great importance in biological system one. First one is chlorophyll. So what is about it? And these pigments responsible for photosynthesis. As we all know that photosynthesis is done by chlorophyll, and photosynthesis though need many other ingredients also, but in coordination compounds, in page number, I can show you the NCERT page. In page number 263, it's written that these pigments are responsible for photosynthesis. The pigments responsible for photosynthesis, that is chlorophyll, is a coordination compounds of magnesium. So what is the coordination compounds? The pigments responsible for photosynthesis, chlorophyll, is a coordination compounds of magnesium. Okay, and hemoglobin is a red pigments of blood which act as a oxygen. Is a coordination compounds of iron. Vitamin B12, cyanocobalto, cobalt, alamine. The anti-pernicious anemia factor is a coordination compounds of cobalt. So I have done my physics class. Sorry, no, chemistry class. So let me revise my chemistry portion, and then I will revise the physics one, and that will be the topic conductor. So coordination compounds of great importance in biological systems. So first one is the chlorophyll, and this chlorophyll is responsible for photosynthesis. Chlorophyll is a coordination compounds of magnesium. Chlorophyll is a coordination compounds of magnesiums. And then about hemoglobin. Hemoglobin, we all know it's a red color pigment of blood. It's a red color pigment of blood, and hemoglobin, it contains oxygen, and hemoglobin is a coordination compounds. In hemoglobin, we find iron. So the coordination, what are the coordination compound? First one we have read about chlorophyll. So what is chlorophyll? Chlorophyll is responsible for photosynthesis, and chlorophyll is a coordination compounds of magnesium. And what's about hemoglobin? Hemoglobin is a red color pigment, is a red pigment of blood. Hb acts as an oxygen carrier, and it acts as an oxygen carrier, and it contains coordination compounds of iron. So Hb contains iron. So Hb is a coordination compound. So what is Hb? Hb is a coordination compound. Hemoglobin is also a coordination compound. Vitamin B12 is also a coordination compound, and cyanocobalamin is also a coordination compound. So these are all coordination compounds, and some informations about them are: first one is chlorophyll. Chlorophyll is a pigment responsible for photosynthesis, and chlorophyll is a coordination compound of magnesium, and this line is written in NCERT. Hemoglobin is also a coordination compound, and hemoglobin contains red color pigment. It acts as an oxygen carrier. So hemoglobin contains oxygen, and it contains iron also. Hemoglobin is a coordination compound. Similarly, chlorophyll is also a coordination compound, and hemoglobin is a red color pigment of blood. It contains oxygen, and it has iron. Now vitamin B12, cyanocobalamin, the anti-pernicious anemia factor, is a coordination compounds of cobalt. So what are the coordination compounds of cobalt? Vitamin B12, cyanocobalamin, and anti-pernicious anemia. These are the coordination compounds of cobalt. Among the other compounds of biological importance with coordinated metal ions are enzymes like carboxypeptidase and peptidase A, and carbonic anhydrase, that is catalyst of biological system. But here I have written notes very beautifully, and from here question will come in Neet. Other compounds of biological importance with coordinated metal ions are the enzymes. So coordination compounds of great importance in biological system are given, and other compounds of biological importance with coordination metal ions are coordinated metal ions are. Other compounds of biological importance with coordinated metal ions are enzymes. So the examples are carboxypeptidase A and carbonic anhydrase, that is the catalyst of biological system. Carboxypeptidase A, and second one is the carbonic anhydrase, that is the catalyst of biological system. Coordination compounds are also used as a catalyst. So coordination compound is used as a enzyme, and second one is the coordination compound is used as a catalyst for many industrial processes like rhodium complex, Winkelson catalyst, and its formula is PH3 whole 3s and RHCl. Wilkinson catalyst is used as a hydrogenation of alkenes. Wilkinson is used as a hydrogenation of alkenes. And the last one is that particles can be electroplated with silver and gold and much more smoothly and evenly from the solution of complex. And the solutions of the complex are AgCN2 minus, AuCN2 minus than from a solutions of simple metal ions. So with the help of the this line means that with the help of the metal, with the help of the metal ions like AgCN2 minus, AuCN2 minus complex ion solutions, many articles can be many articles can be electroplated in a very smoothly and evenly manner. Metal ions so with the help of the metal ions complex ion solution like AgCN2 minus and AuCN2 minus, then other articles means many articles can be electroplated and they are electroplated in a very smoothly and evenly manner. And for electroplated the metals are used, that is silver and gold. So I have revised chemistry and from I think one thing is left and that I will do it tomorrow and I revise this one. At 9 p.m. I have physics class, so I am revising physics now. For physics, my teacher taught me about conductors, and my teacher name is Abhijit Das. I have revealed my teacher name. He is a good teacher. Now see what is a conductor. Okay. A conductor or an electrical conductor is a substance or materials that allow electricity to flow through it. So what is a conductor? A conductor or electrical conductor is a substance. A conductor or an electrical conductor is a substances that allows the material, the electrical substance or matter that allow the electricity to flow through it. When electricity will flow through the conductor, obviously there will be flow of charges. And when there will be flow of charges, obviously there will be electrons. So in basic we can say that electrons are flowing, so that's why charges are flowing. Though charges are flowing, there will be flow of current, right? Yes. So in conductors have large number of free electrons, and they are allowed to move freely within the conductors. Conductors has positive temperature coefficient. Example: copper, silver, aluminium, gold and steel. So free electrons reside inside the volume of conductors. So free electrons reside inside the volume of conductors. So free electrons resides inside the volume of conductors. Free electrons resides inside the volume of conductors. So what is conductors? Conductors or electrical conductor is a substance or materials that allow the flow of electricity through it. A conductor is or a electrical conductor is a substance or materials that allow the flow of electrons through it. Now, electrons flow through it and allow the flow of electricity. Okay, that allow the flow of electricity through it. So when there will be flow of charge, there will be flow of electrons, and due to flow of electrons, there will be flow of current. So what's about the conductor? Conductors have large number of free electrons. All electrons are allowed to move freely. A conductor has positive temperature coefficient. Silver, copper, aluminium, gold and steel. Free electrons are reside inside the conductor. So when we give excess of electrons, that electrons will reside outside the conductor. And if we give excess charge, and that charge can be both positive and negative. Conductors have free electrons. Conductors has low resistance. So due to low resistance, there will be more electricity will flow. Means when there will be low resistance, obviously the current will flow faster. Yes, as we know from the Ohm's law, V equal to IR. So we can write V equal to I by R. So resistance is low. That's why current will flow faster. And electrons in a, if we connect a conductor with a battery, and we all know that a battery has both positive and negative, right? And from which end then the current will flow? From negative to positive it will flow, because electrons can be transferred easily. And negative means there is a flow of electrons, negative means charge of electrons, and positive means charge of protons, and protons cannot be moved due to heavy nuclear force. That's why in a battery electrons are allowed to move, and though negative charge or electron flow, that's why the current will flow. So what is free electrons? Free electron means the neutral body, and neutral body means there will be positive and negative signs, and number of protons and number of neutral body means number of protons and number of electrons are same. And electrons will reside inside the conductor. Electrons will reside inside the conductors, and electrons are moving in the outer orbital. So there is no bond between the free electrons. I revised. Let me revise twice. So what is a conductor? A conductor or an electrical conductor is a substance or materials that allow the flow of electricity through it. So when there will be flow of electricity, obviously there will be flow of charges, and when there will be flow of charges, there will be flow of electrons. Conductors have large number of free electrons, and it allows the electrons to move freely inside the conductors. Though it allows the electrons to move freely inside the conductors, there will be flow of charges, and that charges will produce current. A conductor has low resistance. So from the Ohm's law we get V equal to IR, and then if we modify the formula, I equal to V by R. So the resistance is low, and resistance is low, and I is inversely proportional to 1 by R. So when resistance will be low, and the current will flow faster. Conductor has high thermal conductivity, and when we connect a conductor with a battery, and battery has one negative end and positive end, and though electrons are transferable and protons are not transferable due to heavy nuclear force, so electrons are moving from negative side to positive end. Electrons flow from negative to positive. And when we give excess electrons in a conductors, that excess electrons, not only electrons, it can be electrons or protons, so that charge will reside outside the conductor. So what are the special properties of charge? The source of charge is electrons, and electrons is donated by Q. Charge is a scalar quantity. Charge is quantized, and charge is conservative in nature. Charge is a physical property. It's a physical property because it is not visible. The SI unit of charge is Coulomb, and the CGS unit of charge is Faraday. It's not Farad, and the same mistake I have done in my tuition. I have said Farad is the unit of charge. So leave that. I have memorized that. I will never forget that. SI unit of charge is Coulomb, and CGS unit of charge is ESU. And the smallest unit is ESU, and the largest unit is Faraday. Not Farad. Yes, Farad is the unit of capacitor. 1 Coulomb equal to 3 into the power 9, 3 into 10 to the power 9 ESU, and 1 ESU equal to 1 by 3 into 10 to the power minus 9 Coulomb. And though we are studying electrostatic force, so the unit of force is Newton. SI unit of force is Newton, and the CGS unit of force is Dyne, and 1 Newton equal to 10 to the power 5 Dyne. Yes. Charge is additive in nature. Charge is quantized. Quantized means it should be available in the market. So it's my for own understanding I have written like this. So it should be in fixed amount, and quantized means it should be in integral number. So the formula is Q equal to Ne. Q equal to Ne, and Q means the charge of any body, and N is the integral number. Is the charge of an electron, and charge of an electron is 1.6 into 10 to the power minus 19 Coulomb here, because we have to take the magnitude. The charge of an electron is minus 1.6 into 10 to the power minus 19 Coulomb. Charge of a proton is plus E, that is plus 1.6 into 10 to the power minus 19 Coulomb. And charge of a proton, charge of a positron, charge of a deuteron is same, and that is plus E, that is 1.6 into 10 to the power minus 19 Coulomb. And when the charge is in fraction, and fraction is in small amount, that like 1.2, 2.3 or similar like that, then the net charge will be 0. And when the charge will be in fraction, but its fraction is in large amount, then it's then we can calculate the value of charge. And that, for example, find the charge on 7.5 into 10 to the power 17 Coulomb. 17 is a question. Yes, 17 electron. Find the charge on 7.5 into 10 to the power 17 electron. Then we can write that the charge will be minus 7.5 into 10 to the power 17 into 1.6 into 10 to the power minus 19 Coulomb, and calculate. You can solve that. Have I missed anything? No. Charge are of two types. First one is positive, and second one is negative. And when there will be excess of electrons, we get positive charge, and then the mass number will be increased. And when there is deficiency of when there is excess of electrons, we will get negative charge. And when there will be deficiency of electrons, we will get positive charge. When there is excess of electrons, positive charge, and excess of electrons, that means it will be negative charge. And negative charge means excess of electrons, the mass number will be increased. And when there will be deficiency of electrons, that is the charge will be positive. And positive means deficiency means losing of electrons, the mass number will decrease. A charge can exist without mass, but a mass cannot exist without charge. So a body can be neutral. A charge is made up of neutron, that is its value will be 0, and neutron is made up of equal charge, but neutron is neutral. For neutral body, the number of proton, number of electrons are same. X equal to for an atom we get X equal to Z. Consider the diagrams of an atom. So means skeleton diagram. So for an atom we write X for element, and A indicates mass number or the proton number, and Z indicates the mass number, Z indicates the atom number, the electron number or the proton number, and we get neutron from A minus Z. We can find out the net charge, and to calculate the net charge we have to consider electrons, protons and neutrons. A body can be charged by transfer of electrons from Transfer means that electrons can be given to a body and that electrons can be taken out from that body. A proton cannot be transferable because proton has heavy nuclear force and it's connected with a neutron, and its bond is so strong that if we want to take out that proton we need high energies. And for electron is transferable because it has no strong bond and is situated in the outer orbital, so it is transferable. There are three states of charge. First one is the charge should be at rest and the charge is moving with constant velocity. When the charge is moving with constant velocity, that means charge is moving slowly, and the charge can be moved with the state of charge can be in the accelerated manner. As we all know that charge is a property, so it will lead to effect. So when the charge will be at rest, its effects will be electric field, and when the charge will be when the charge is moving with constant velocity, its effect will be electric field and magnetic field. And when the charge is moving in accelerated manner, it will produce the effect and effects will be electric field, magnetic field and EM wave. The charge of an electrons and protons are same because it denotes the protons are same because though their signs are different. The charge of an protons and electrons are same though their sign of the charge are different, because this indicates the property, it doesn't indicate the value. So what is property? Property indicates the characters, and when there will be a property and property will lead to effect. When there will be property, that property will lead to effect. And properties example is mass, and mass will obviously lead to effect. So what are the effects of mass? The effects of mass is gravitational force. The effects of mass is moment of inertia. So what is the formula of gravitational force? The formula of gravitational force equal to F equal to G m1 m2 by r square, and the formula of moment of inertia equal to I equal to m r square. Charge is also a property, and this property will lead to effect, and this effect will be electrostatic force. Obviously lead to effect, and its effect will be electrostatic force. And when there is no property, obviously there will be no effect. Mass is a quantity of matter that contains in a body. So mass has many compositions. So quantity has many compositions. The property due to which it apply or experience gravitational force. So gravitation is attractive. What I said, property of an object which apply or experience gravitational force is always attractive. So gravitational force is always attractive. So mass is a property and it will result in effect, and effects will be gravitational force and moment of inertia. And charge is also a property and its effect will be electrostatic force. I have completed my physics revision. Let me revise chemistry from first. Okay. Limitations of crystal field theory. Crystal field model successfully explains about the property of coordination compounds, and the properties of coordination compounds are the formation, structure, color and magnetic properties. Crystal field theories has ligand, and that ligand act as a point charge. As a result, anionic ligands iodine, fluorine, chlorine, bromine should exert the greatest splitting effect. So what is anionic ligand? The anionic ligand actually are found at the lowest end, and the lowest end means it should be present at the left side of the spectrochemical series. Anionic ligands does not take into account the covalent characters of bonding between metals and ligand. We all know the covalent bond means there will be sharing of electrons, and that electron should be unpaired. And unpaired electrons only lead to sharing, and this will create a bond, that is the single bond. Anionic ligands are found at the left side of the spectrochemical series. Okay. Anionic ligands are some of the weakness of the CFT, which are explained by the ligand field theory and molecular orbital theory. Anionic ligands are some of the weakness of the CFT, which are explained by ligand field theory and molecular orbital theory. And bonding in metals, and here the metals will be the transition metals. Bondings means there will be double bond, and metal will be the transition metal. So what are the transition metals? The examples of transition metals are scandium, platinum, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. And carbonyl means there will be carbon and bonded with oxygen, and there will be double bond between them. So what is homoleptic complex? When one type of ligand is connected with the homoleptic complex means a coordination compounds in which there is one type of ligand. I am saying the one type of ligand, not the number. For example, PtCl4 2 minus. So you can consider there are Cl4, there are 4 ligand. No, you have to see the type of ligand. Here there is one type of ligand, that is chlorine. So PtCl4, Cl4 has one type of ligand, that is chlorine. When a coordination compounds has more than one type of ligand, that is heteroleptic complex. For example, PtNH3 2Cl2, and Pt is the metal, and Li is NH3, and L2 is chlorine. So there are L means what? L means I am telling about ligands. So there are two ligands. One is NH3 amine and chlorine. So when the ligands are 4 in number, their shape will be tetrahedral, and when the ligands are in 6 in number, their shape will be octahedral. Homoleptic carbonyl compounds. Only carbonyl C double bond O ligand has some relation with this compound. Homoleptic carbonyl compounds, only carbonyl compound has some relation with this compound. And homoleptic means homoleptic carbonyl compounds formed by most of the transition metals. So transition metals form most of the homoleptic carbonyl compounds. These carbonyl compounds have simple and well defined structure. These carbonyl compounds have very simple and well defined structure. Only one type of carbonyl compounds ligand is used. So there are many examples of homoleptic complex compound. For example, tetracarbonyl nickel. So its oxidation number is 0, and though the ligand number is 4, it will be tetrahedral pentacarbonyl iron. So FeCO5, its structure will be trigonal bipyramidal, and its oxidation number is 0. Hexacarbonyl chromium, FeCO6, its structure will be octahedral, and its oxidation number will be 0. Decacarbonyl dimanganese, its oxidation number will be 0, and its structure will be, there will be 2 square pyramidal, and there is no bond bridge. But in octacarbonyl dicobalt, there are 2 bridge bond. Bridge bond and bond bridge. There are difference between bridge bond and bond bridge. Okay. So for octacarbonyl dicobalt, it has cobalt bond bridge. Means when cobalt is connected with cobalt, there is one bond bridge, and 2 carbonyl metals. Here the bridge bond is present. Here bridge bond is present, and there are 2 bridge bond. Here the bridge bond is present, and there are 2 bridge bond. So decacarbonyl manganese. Deca means 10. So decacarbonyl dimanganese. Obviously there are 2 manganese. So 2 manganese are formed, and its structure has 2 square pyramidal. It has no bridge bond. There is no bridge bond. But the octa cobalt carbonyl has 2 bridge bond, and it has cobalt bond bridge. And that's the thing. Yes. What is mononuclear? What is dinuclear? What is trinuclear? What is tetranuclear? Nuclear means metal. And when one type of metal is connected with the ligand, when one type of metal is connected with one type of ligand, when one metal is connected with one type of ligand, that is mononuclear. When one metal connected with one type of ligand, When one metal is connected with one type of ligand, that is mononuclear. When two metal is connected with one type of ligand, that is nuclear. When three metal is connected with one type of ligand, that is trinuclear. When four metal is connected with one type of ligand, that is tetranuclear. So what is organometallic compounds? So split the word organo, split the word metal, split the word compound. So organo means organic, and from organic it clicks to our mind. It should be it will deal with the carbon. And in the here metal will be the transition metals. The compounds in which metal is directly bonded with the carbon, that is known as the organometallic compound. The compounds in which metal is directly bonded with the carbon, the compounds in which the metal is the compounds in which the compounds in which the metal is directly bonded with the carbon, that is organometallic compound. The compounds in which the compounds in which the metal, and what type of metal? There should be transition metal. The compounds in which the metal means the transition metal directly bonded with the carbon, that is known as the organometallic compounds. And there are two types of organometallic compound. First one is the ionic organometallic compounds. The second one is the covalent organometallic compounds. So ionic organometallic compounds, the first split the word ionic and split the word organo, split the word metallic and split the word compound. So first one is ionic, and ions deals with the ions. So there are two types of ions. First one is the cation and second one is the anion. So anionic bonds present with the metal and carbon. An example are Li plus, R minus Li plus, and R triple bond C. That is the thing. And covalent bonds. Covalent means there will be sharing of electrons, and this bond is found between the metal and the ligand. So there are three types of covalent bond. First one is the sigma bond, second one is the pi bond, third one is the sigma and pi bond. So sigma is formed between the two unpaired electrons, and there is sigma is formed between the two unpaired electrons, and then when the two unpaired electrons is connected with the bond, and that is known two unpaired electrons helps in formation of one bond, that is the single bond, and that is known as the sigma bond. Our example of sigma bond is CH3SN. SN is the tin, and CH3 is the R group, that is the methyl group. And another example is RMGX. RMGX is the Grignard reagent, that is the organic reagent. And if we want to find out the sigma bond between the RMGX, then it will be 5. And Al2Me6. So number of sigma bond between metals and carbons, that is 8, not 9. Pi bond. So pi bond, so pi bond is found between the double bond. So when there is the double bond, there will be one sigma bond and one pi bond. When there is triple bond, there will be one sigma bond and two double bond. When there is and when there is one triple bond, when there is single bond, there is one sigma bond and 0 pi bond. And for ferrocene, Fe into the power 6, what is the formula of ferrocene? The formula of ferrocene will be Fe n to the power 6 C5H2 whole twice. That is the formula of ferrocene, and the hapticity will be 5. What is the meaning of hapticity? Hapticity means the number of carbon rings or number of chain, carbon rings or the linear chain. Dimenzene chromium. Formula of dimenzene chromium Cr n to the power 6 C6H6 whole twice 2, and the hapticity will be 6. For this solve PTCl3, K bracket PTCl3 n to the power 2 C2H4, and its hapticity will be 2. K PTCl3 n to the power 2 C2H4. K PTCl3 n to the power 2 C2H4, its hapticity will be 2. And sigma and pi bond is found between the metal and the ligand. So NiCO4 is it will be tetrahedral, and its hybridization is sp3. And MnCO5 it will be dsp3. MnCO5 its hybridization will be dsp3, and it will be trigonal bipyramidal. FeCO5, that its FeCO5 its hybridization will be dsp3, and it will be trigonal bipyramidal. CrCO6 D2sp3, and it will be octahedral. MnCO10, there will be two trigonal bipyramidal. CO2, CO8, and there will be 2 tetrahedral unit. Bonding in carbonyl compounds. So for the bonding in carbonyl compounds, we need metals and carbonyl compound, and carbonyl compound is CO. It is also known as carbon monoxide, and it is a strong field ligand. So for metals, we have 5 orbitals, and one orbital will be vacant orbital, and 4 orbital will be full filled orbital, and there will be sidewise over for now leave that. So there is one metals and there is one carbonyl compounds, and carbonyl compound has there will be lone pair. There will be one lone pair only, and one lone pair has 2 electrons, and 2 electrons means there will be 2 electrons, and 2 electrons form a bond. And carbonyl compounds are pi antibonding orbitals and pi star antibonding orbitals. Now for metal carbon sigma bond, for sigma bond there will be head-on overlap. So when there will be head-on overlapping, that's why only sigma bond will form. So from the lone pair, a lone pair contains 2 electrons. So these 2 electrons from the carbonyl compounds it will transfer to the vacant orbitals of the metal. As I have already said that metals has 1 vacant orbitals and 5 full filled orbitals. So that forms a sigma bond and metal carbon pi bond. When the metal carbon's full filled orbitals lone pair is connected to is transferred to the carbonyl vacant orbitals, which orbital? Pi star antibonding orbitals, and then only metal carbon pi bond is formed. Is formed by sidewise overlapping, that is known as back bonding donation. And this will create an effect, and that effect is known as synergic effect, and it strengthens the bond between the carbons and the metals. So carbonyl compound is a strong bond. It is also known as carbon monoxide. It is acid pi ligand, and acid pi ligand is formed by the antibonding pi star orbital form. So application of synergic effect due to synergic bonding, charge density. So due to synergic bonding, metal carbon bond. So here bond energy will increase. Though the bond energy will increase, the bond order will increase. Though the bond order will increase, the bond length will decrease. For the charge densities on metal, say this is the same thing for metal carbon. Bond energy will increase, bond order will increase, bond length will decrease. And for the CO and for the carbonyl means CO carbonyl compounds, bond energy decrease, bond order also decrease, and bond length increase. And for the metal carbon bond, charge density will be negative greater than neutral greater than positive, and for charge density of the metal will be positive greater than 0 greater than negative. And if a question and synergy effect has bond which has very minimal difference, and if CO bond length in CO is 1.128 Armstrong, then what is the value of the CO bond in FeCO5? And this option is given 1.15 Armstrong, 1.128 Armstrong, 1.72 Armstrong, 1.118 Armstrong, and this question will come in Neet because, and you can solve it without pen and paper. As I have already said, synergic effect bond has very minimal difference. So that's why it will be 1.15 Armstrong. Compare the CO bond length. A means he sold twice. CrCO6, AbCO5. If you have to find out the oxidation number gives the charges. So Mn2 plus. So for covalent for CO bond, we will get what we will get for CO bond. For CO bond, we will get positive greater than 0 and negative. And you can solve this question. Pi sigma, sigma pi. Pi sigma. Okay, now I have to take rest because I have class from 9. Okay, thank you. I have done physics revision and chemistry revision. Please like and subscribe my channel.